Okay, this is section 7 for chi-square, and this is for fall 2022. This will be the last section that we cover. Number one, find a critical value for chi-squared right. Sample size is 3. Confidence level is 95%. First thing I did was to draw my curve. Obviously, it's not quite a bell-shaped curve. It's skewed to the right. In either case, I'm looking for, I want to be 95% confident, so 95% 0.95, the area in the middle. If I take 1, subtract 0.95, gives me a remainder of 0.05 that's shared equally amongst these two areas in the red or pink, whatever color you want to refer to it as. So take the difference between 1 and 0.95 leaves you 0.05 shared equally. So dividing that by 2, each one of these small areas to the left and right equal 0.025. So if I'm looking for chi-squared right, it's a right-handed table as opposed to what we did when we first started this off back in the day where we're using left-handed tables. So, in fact, that was going back to chapter 6. In either case, right-handed table. So the area to the right of chi-squared right is 0.025. Now, my degrees of freedom is n minus 1. 3 minus 1 is 2. So I match up 2 degrees of freedom with an area to the right of 0.025. There I'm reading my chi-squared right value, 7.378. Number 2, once again, we're looking for chi-squared right. Sample size is 5. This time we've got a 98% confidence interval. So if I take, let's see, my area in blue here, 98%. If I take one whole, the area under the whole curve, subtract 0.98, that leaves 0.02 shared equally amongst these two areas in red. 0.02 divided by 2, each one of these areas contains an area of 0.01. So if I'm looking for chi-squared right, the area to the right of this value is 0.01. So if I match that up with 4 degrees of freedom, since my end value is 5, 4 degrees of freedom, an area of 0.01, they intersect at 13.277. Number 3, we switch up. Now we're looking for chi-squared left. We got a 95% confidence level. So if I take my area in blue here, my main area, 95%. If I take one whole, the area under the whole curve, subtract this area of 0.95, I'm left with 0.05. That's shared equally amongst this lower level in red and the upper level. So half of 0.05 is 0.025. All right, so that's the area here to the right and this area to the left. Now, if I'm looking for chi-squared left, the area to the right of this is from here all the way to the end. So if the area under the curve is 1 minus the smidgen of 0.025, the area from here, chi-squared left, all the way to the very end is 1 minus 0.025 or 0.975. It's a right-handed table. So if I match up 23 degrees of freedom, sample size was 24 minus 1 gave me 23 degrees of freedom. Matching 23 up with 0.975, I'm reading my chi-squared left value as 11.689. Number 4, once again, we're looking for chi-squared left. My confidence level is 98%. That's the area in blue. If I take one whole, the area under the whole curve, subtract this area of 0.98, I'm left with 0.02 that's shared equally amongst these two areas in red. Half of 0.02 is 0.01. 0.01 here and 0.01 here. Now, if you're looking for chi-squared left, it's a right-handed table. So the area from this point all the way to the end is one whole. Subtract 0.01, this little smidgen of 0.01, leaving from here all the way to the very end as being 1 minus 0.01, 0.99. So if I match up 16 degrees of freedom, because my end value was 17, one less than that is 16, I match that up with 0.99, I'm reading my chi-squared left value of 5.812. 5.812. And these match up perfectly. There's no discrepancy at all. So if you're not getting the right answer, unless one of these answers here is somehow done incorrectly, but I don't even want to think about that. I want to think about how to do something wrong. All right, so we move on to remaining examples. We're asked to take it one step further. We need to find the entire confidence interval. The first thing I'll mention is that in the video with Big Al, he had S outside of the square root. All right, he took the square root of S squared, he had S outside. This, in my estimation, is just as easy, if not easier, using this formula. And obviously, when you print this out, you'll have the formula for the population standard deviation and interval. All right, so what are we given here? Weights of men, we want to be 90% confident. N is 14, which makes my degrees of freedom 13. He gives me X bar, which is completely unnecessary. There's no need for X bar. The only thing I can think of is trying to mess with your head, thinking that you use X bar instead of S in the formula. The formula doesn't call for X bar at all. We're not even worried about the mean. We're worried about standard deviation. So please don't get confused about that. That's needless information. All right, so I'm 90% confidence. You got to draw the curve here, all right? Large, whether or not it's exactly like my curve, it is slightly skewed. All right, it's not bell-shaped exactly. Anyways, 90% is your confidence level. So take one whole, subtract this area in blue, 90% leaves you 10% that's shared equally amongst these two areas in red. Each one of these areas is half of 0.10, 0.05. So starting out with chi-squared right. All right, so the area to the right of this value, to the right is 0.05. All right, so matching up 0.05 with 13 degrees of freedom, I'm reading my chi-squared right value as 22.362. Now, when it comes time to find chi-squared left, the area that's associated with this value is from here all the way to the very end. If this smidgen here is 0.05, from here to the end is 1 minus 0.05, 0.95. All right, so there's my area, 0.95, matched up with 13 degrees of freedom. I'm reading a chi-squared left value of 5.892. All right, so now I do the right first, all right, with a bigger value. All right, so it's n minus 1. N minus 1 is 13. There is my standard deviation. It's 10.9. I'm squaring that and dividing it by my chi-squared right value of 22.362 right there. And I get 8.3. Doing the left, I'm doing the same thing here. I'm taking my n minus 113. There's my S value squared, my standard deviation of sample squared, divided by my chi-squared left value of 5.892, and you get 16.2. Now, if you're pretty adept at this, you're going to see something happening where I could have picked letter A without even doing the chi-squared without even doing the maximum value of 16.2. What I'm saying here is that when I did this guy here, my chi-squared right, I got 8.3. All right, there was only one answer that had my lower value of 8.3. All right, so I could have not even done this, but I did it to make sure that everything was spot on. I'm not sure that's going to happen all the time, but it's interesting that there was only one that had the correct first answer, 8.3. Number 6, you're looking for a 95% confidence level, and it's 22. You don't need X bar, it's meaningless. Put a line through that. There's your standard deviation of your sample, 0.33. 95%. All right, so that's in blue. If I take one whole, subtract 0.95, I get 0.05 that's shared equally amongst the two areas in red. Well, half of 0.05 is 0.025. The smidgen here is as labeled 0.025, and that's small area there is 0.025. All right, going to my chart, finding chi-squared right. I'm matching up 21 degrees of freedom. The area to the right here is 0.025. And then I'm reading a value for my chi-squared right, 35.479. To calculate chi-squared left, it's the area to the right, from this vertical line all the way till you can't go any further. If this smidgen is 0.025, then the area from here all the way to the right is 1 minus that, one whole minus this little smidgen, 0.975. If I match up 0.975 with 21 degrees of freedom, I read a chi-squared left value of 10.283. All right, so I start out by doing my chi-squared right. There's my n minus 121. There's my standard deviation square, like the formula calls for. Chi-squared right is 35.479. Correct to two places, 0.25. Well, there's a case where I see 0.25 there and 0.25 there, so I can't play that little game I was playing before in the previous example. I've got to calculate my upper limit. So upper limit here would be n minus 1, which is 21 degrees of freedom. There's my s squared, like the formula calls for. Chi-squared left is 10.283. And the calculator very nicely returns 0.47, so I know it's letter A versus being letter B. These will always, there'll be no discrepancy. These will always be spot on, which is kind of nice. Number 7, 98% confident, and is 9. I could care less what X bar is. My standard deviation is $886. So 98% in blue, which means that there is 2% left to be shared equally amongst the areas in red. Well, half of 0.02 is zero point 0.01. So this area here in red is 0.01, and this smidgen here is 0.01. Chi-squared right, the area from here, this point, this vertical line to the right, 0.01. If I match that up with 8 degrees of freedom, I should have put a little yellow mark there, I didn't. 0.01 with 8 degrees of freedom, I'm reading 20.090. Chi-squared left, from this vertical line all the way to the right, it's a right-handed table. It's one whole, the entire area, minus this little smidgen in red. The remaining area is 1 minus 0.01 or 0.99. If I match up 0.99 with 8 degrees of freedom, 1.646. Plugging, doing my chi-squared right first. All right, this lower limit here. There's my n minus 1, my degrees of freedom. There's my standard deviation squared, like the formula says, divided by chi-squared right of 20.090, 559. Now here's one where I only see one answer with 559 for the lower limit of the confidence interval. It tells me it's letter B, but I went ahead and did the other one anyways, just to show you that it works out. Same idea, it's n minus 1, there's my s squared, 886 squared. Chi-squared left is 1.646. Correct to no decimal places, 0 decimal places, 19.1953, 1,905, 1,953. I can spit it out. All right, letter B. All right, number 8. Here I just highlighted standard deviation. I didn't want to get confused with the mean being 9.4 kilos. 99% confidence interval. All right, so that's the area in blue, the major area. So the remaining is 0.01 area left, shared equally. With the two areas in red, half of 0.01 is 0.005. 0.005 here, and this area here, 0.005. Calculating chi-squared right. So I'm matching up 0.005 with, here again, I should have labeled this. I should have put a little mark here. That's 19 is my degrees of freedom. Anyways, you see it. 19 with 0.005. chi-squared right, 38.582. And once again, if this smidgen here is 0.005, one whole minus this little smidgen gives you an area from this vertical line to the right of 0.995. 0.995 matching up with 19 degrees of freedom, 6.844. All right, doing chi-squared right first. There's my n minus 1. 20 minus 1 is 19. There's my s value squared. There's my chi-squared right, 1.8. Well, there's three answers that start out with a lower limit of 1.8. So I have to do the upper limit. Upper limit 19, which is my n minus 1. S is still 2.6. I'm squaring it, dividing it by my chi-squared left score of 6.844. And I come up with exactly 4.3. Voila, letter B, spot on. Number 9, 95%. We've seen this before. One whole minus 95 leaves 5% shared equally amongst the two areas in red. Half of 0.05 is 0.025. So finding chi-squared right. Now here I did 18. Okay, Mr. Gomes, you're getting better. All right, it's 18 degrees of freedom matching up with an area from this vertical line to the right of 0.025. There it is, 31.526. Chi-squared left, if this smidgen is 0.025 right here, way to the left, remaining area to the right is 1 minus that, 0.975. From here all the way to the right, matching up 0.975 with 18 degrees of freedom. My chi-squared left score, 8.231. Going back to my calculator, doing the chi-squared left score first. There's my degrees of freedom. There's my standard deviation, 0.16. That's 16.16. Divided by chi-squared right, 0.12. And here's one where I don't see any other answer that has a lower bound for my confidence interval of 0.12. Theoretically, I'm done. If I feel confident, I'm done. But if I don't feel that confident, I'm going to do the upper level. There's my degrees of freedom, 18. There's my 0.16, my standard deviation squared, and then my chi-squared left score, 8.231. Correct to 2 decimal places. You know, I said this over and over again. Look at the answers before you do the problem. Go to mode, set your mode to the exact same number of decimal places. It takes literally 5 seconds. And then you don't have to worry about rounding off or anything, because these answers will be spot on. And notice I could have actually stopped after I got 0.12. I feel very confident, and why wouldn't I? Number 10, sociologist develops a test to measure attitudes about public transportation. All right, 27. All right, there's my n value, which means my degrees of freedom is one less than that, 26. 95%. All right, the area in blue, the major area. And one whole minus 0.95 gives me an area that's left of 0.05 shared equally amongst the bottom right and the top left. Half of 0.05 is 0.025, this area here and this smidgen there. Finding chi-squared right. And what I didn't do was to finish this off for some crazy reason. And what I'll do is I'll have to do this one in class. I don't know why I didn't do that. But when you download it off of the web, I'm not going to re-record this, but when I have this file ready, I will actually have the correct, I'll have the full thing done out. Need a case, I'm pretty sure, number 10. I'm not sure what it worked out to be quite honest, but I'll do it in class. I'll figure it out which one it was. That's interesting. It's the first time that's happened. All right, hope this helps.